Welcome to the Lesson 6 quiz. And we'll go ahead and get started. It says select the correct statement, number 1. Select the correct statement about basement walls. Let's just go down the list and cross off what is wrong, and then we'll figure out what's right. A. Drainage is usually provided by weep holes through the wall. And this is talking about basement walls. I would say no. You do not want weep holes to come through the wall because that will get water in your basement, so that doesn't make any sense. So A is no. B, the wall should be designed to resist earth pressure unless a granule backfill is used. That is also false because when you have granular backfill, you still design to resist earth pressure. It may be better. That granular backfill is typically better and it will drain better, so you're not going to have water backup behind that wall, water pressure as well, so it'll be less, but you still need a design for earth pressure. So B is wrong. C, the wall is usually designed to cantilever from its footing since the floor construction is not permitted to laterally support the wall. So it says this is the basement wall, so it's saying it's going to cantilever. So here's your footing, I guess. But I would say that this is incorrect. No, not necessarily though. But usually, basement walls, you'll have a wall right here, and then you'll have the basement floor. So it will be I guess you could call it a pin right here. The fact is, it'll be resisted right there. So it's not a cantilever, but you could theoretically you could have an instance where it is a cantilever. So that's a maybe, but probably no. Let's go ahead and see what D is. The reinforcing steel should be placed near the inside face of the wall. So they're saying the inside face, assuming this is your fill face. And this is your house over here where you're building structure. The inside face of the wall. And if you had a cantilever, that would be incorrect. So you had a cantilever. This is your wall. The earth pressure would look like that, and therefore it would push it this way, and you would want the reinforcing on this side of the wall. But since we're assuming that most basement walls will be, if not all, I guess I don't like saying all. I never like making those broad statements saying every single time, because there could be some wacky instance where you don't have a wall right here. It just goes straight to the basement. I know architects might think that's cool. So I don't want to say all the time. Typically, you will have a floor here. It will be braced, and therefore you will have this type of situation where you want to look at it where the earth pressure will be over here. So that's your wedge, and it will create that type of moment, and the inside will be in tension, and therefore yes, typically you will want your reinforcing, let's change colors here, to be on the inside face in a basement wall. So I'm going to say D is the most accurate statement. The reinforcing steel should be placed near the inside. And as we said, C is kind of the opposite of that. And we said that typically you will have this situation and you will not have a cantilevered situation. So I'm going to go ahead and say that D is your correct answer. Let's look at the back and see what they got. And they also say that it is D. So let's go with D. And I hope that makes sense to you why. If not, go ahead and try to look at what I just said to explain and think about it yourself, where you would put that reinforcing steel based on what type of moment you have. All right, moving on. Number 1 is D. Going on to number 2, select the correct statements about retaining walls. All right, not a problem. Let's just go down the list. 1, counterfort walls are not economical for walls 25 feet or higher. And a counterfort wall looks like it's a cantilever wall. Here's your typical cantilever wall, except it has these counterforts at certain intervals, which is a concrete wall. So if you're looking at it in not the cross-section view, more of an elevation view. Well, here is your footing, and then here's your wall. There's the top of your wall. Whoa, sorry about that. All right, you would have these counterforts in here, and they obviously be reinforced in whenever you need them. So it would actually, these help reinforce this, because remember, you're getting this pressure going this way, and I'm not making it a wedge this time because it would be confusing since there's something that already looks like a wedge. But it would help resist that moment instead of this being your depth. Now, if you had, of course, if you had reinforcing in here, remember it's gonna deflect like this, meaning you want your reinforcing on this side because it's going to be in tension. Let's think. This would probably have some reinforcing right there, and this would want to be probably something like that. Which I would just put reinforcing in this entire thing, but that's me. That's typically what you do. What we'll do is put number 4s on the back side, and then you design your positive moment side as a, I can't say positive moment side, that doesn't make sense, but your tension side as what you need, and then you just put maybe number 4s at 12. All right, I guess you don't have to, but that's what we'll typically do. And then you'll have, sorry, it's kind of going off the tangent, then you maybe have some certain bars going longitudinally as well, like so. Whoa, that kind of flew away. So you'll have bars going like that as well. Maybe number 4 bars or whatever you feel comfortable with, and go through the ACI code and see what you feel comfortable with, see what previous designs are. Anyways, where was I at? Sorry about that little tangent right there. So instead of having this be your depth from here to here, you now have, if you have that, you have this being your depth, which gives you a lot more. You can look at it as like a T section now. Now looking from a plan view, you would see it like, there's your wall, and then here's your T section. So you would get this, and remember it's going that way, so if you put stuff in here, that would be your compression flange, and now you'd have your compression block, and then you'd have these steel, it gives you a much longer, you could call it moment arm, but you could also call it a much longer force couple, and I hope that makes sense. But I'm going to stop. I'm going to stop right there because I don't want to try to explain things. I'm trying to keep these things simple and move on from there. All right. Where did we leave off? Let me get off on these tangents and I forget where I left off. All right, we left off. That was number 2. Number 1, and I said that says counterfort walls are not economical, and that's not true, because they actually say on page 109 this type of wall is more economical than the cantilever wall for heights over about 25 feet, and that made sense. We just explained why, but that is a not correct statement, so that's untrue. So we're going to cross out number 1. Number 2, gravity walls are the most common type of retaining wall and consist of stem, keel, and toe. And that is incorrect, because a gravity wall, you can see on page 109, is just a big hunk of concrete. And a lot of times dams are made out of a gravity wall. It's just like the Hoover Dam. It's just this giant wedge of concrete. And it stays in place because it just has so much mass that it doesn't move. I think that's the easiest way to explain it. But you could go in and you need to look at the pressure compared to what you need to do is go in and you need to take a look. For instance, there's your big hunk of concrete. Let's say you had a dam, or let's not say dam since we're not talking about that, but here's your wall, here's your other wall, and let's say the center of gravity would be where about right here. So we know that the weight, your force, weight is force. It's going to go through the center of gravity, and therefore you can work out your moment arms. You can figure out, sorry, that's a little high, your equivalent pressure, force from the earth wedge. It's going to be like that. That's your equivalent pressure. And you have to figure out your moments and make sure it's not going to fall over. That's pretty much as easy as it gets. And you also need to, it also needs to be deep enough. I know I haven't gone over sliding yet, but to make sure it doesn't move this way. You know, it has to be a certain amount deep, and this is going to have passive pressure over here, and they didn't even mention any passive pressure, and that might be overstepping what the architectural structure is. So you're going to actually have a passive pressure over here, and sometimes active, or you call it static. Sometimes static. I always use active most of the time. Active pressure means you're pretending like the wall is going to move this way, and then passive, in short, means that the wall is pushing into your earth, and it's actually has a stronger force. So you need less passive. And actually, it kind of depends how you want to look at it. If it's a stone, you could look at it like that. So, anyways, I'm going to stop right there and try not to say too much. But that is incorrect. Number 2 is incorrect. The type of retaining wall that has a stem, heel, and toe is typically your cantilever wall. It could be the counterforge. You could say that it is. You have a heel, a toe, and then you could say you have a counterforge as well, I guess. But that is incorrect. Let's go on. I'm moving incredibly slow. Only on number 2, but that's why these quizzes take a few parts. All right, for number 2, answer number 3 is a retaining wall is necessary whenever the ground elevation changes abruptly. And that could be true, or it doesn't have to be true. And that's why I never like these word questions, because if it's only a few inches, you could look at the. You could look. Kind of depends what situation you're in. If you're in a temporary condition, you have soil engineers actually look at the soil and say, "Oh, it's only a foot drop." You know, if we excavate, let's say they had to excavate this soil, and this is only a foot. You could have a soils engineer look at this drop and say, well, this is really clay. As long as it doesn't rain, you don't have to do that. Also, if it's just really small, you'd have soils engineers say, well, you don't have to. Typically what they'll do is they'll slope it, you know, at a 2 to 1 or 2 to 1.5. Depends on what type of soil and what type of thing you're having. But I think what they're trying to say is, yes, you want to have a retaining wall whenever the ground changes elevation. I don't like this at all, though. I don't like number 3 at all. I would answer no, but I've already looked at the answer. The answer is actually D, 3 and 4, so they want to say yes for 3. Once again, leave it up to your interpretation. Okay, so 3, we're going to circle yes, even though I may not agree with it 100%. Then let's go to 4. The total earth pressure on the stem for a 1 foot length of wall is equal to 30 h squared divided by 2. Let's take a quick look at that. 30 h2 divided by 2. Let's run out a little low on time here. So here's your, your stem. The total earth pressure on the stem for 1 foot. And we know that's not right because it's but it's going to be 30. Let's assuming that your PCF times your height times your height again divided by 1/2. So I guess that is true. The total earth pressure on the stem for a 1 foot length of wall is equal to 30 h squared divided by 2. 30 h squared divided by 2. And it says I don't like this because it's not always going to be 30. This is not correct. It's not always going to be 30. So that's a maybe. But it looks like they said yes. Then let's go move on to number 5. Low retaining walls are most often constructed of reinforced brick masonry. And it says right here, it says low retaining walls on page 109. Low retaining walls are often constructed of reinforced concrete block masonry. So it's actually a concrete block instead of brick. So that's not true. So go with D, which I'm not a big fan of this answer, but D is all right. So number 2 is D, both 3 and 4. I will see you on part 2 of the lesson 6 quiz.